What's up, recalculus students? Mr. Messner. We'll walk through this homework 8-2. We're finding these inequalities. First thing to do is to find the equality. It's important to know when things change signs, they always change signs through two different situations. And you can look at this graphically. You can change signs from positives to negatives through a zero. You can also change signs through an asymptote or potential jumps. Okay, so when things are undefined, when you don't have a defined value, or zeros. For right now, zeros are the important part. My cursor is going to disappear on me a couple times, so you might see me doing this. Technology. All right, so I got to try to factor this to solve. Now we notice this is very close to looking like just a regular quadratic, but it's with x to the fourths. That must mean we're not talking about x plus something. We're talking about x squared times x squareds. X squared times x squared is x to the fourth. X squared times this number plus x squared times this number will give us the middle term. Okay, so two numbers that add to get 16 and add to get negative 17 and multiply to get 16 are negative 16 and negative 1. So I have negative 16 and negative 1. We're finding when this equals 0. Now for these, you can factor, or we can just know what the answers are. And they are when x is negative 4, negative 1, 1, and positive 4. So I'm going to throw those all down on a number line. Now you can think about this two-dimensionally. You could graph this x to the fourth, x to the fourth positive, it's going to be, down, up, or you can just use test points. I like to use test points. It's what we use in calculus. So I like to start over here, like 5. And it's very easy you don't have to figure out what the number is. It's just is this positive or negative? So 5 plus 4 is positive. 5 minus 4 is positive. 5 plus 1 is positive. 5 minus 1 is positive. What's a positive number times a positive number times a positive number times a positive number? It's positive. Let's plug in something in between 1 and 4, because these are all zeros. Negative 4, negative 1, 1, 4, those are all going to be zeros. And we know that, you can bounce off a 0. Sometimes you bounce off a 0 if you have a multiplicity of 2, even multiplicity, not just 2. You have an odd multiplicity you go through. All of these multiplicities are 1. So we could just simply say negative, positive, negative, positive. And we'd be safe because we know about multiplicities. We know that we pass through the 0. So we just need 1 if we understand that. It is good to check. It is good to make sure you know. Don't just assume we're changing unless you're focusing on multiplicities. I'm going to just test by plugging in points like 3. Okay, 3 plus 4, positive. 3 minus 4, negative. 3 plus 1, positive. 3 minus 1, positive. So I got positive, 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 negative. So one negative makes it all negative. Okay? Positive times positive, positive, times another positive, positive, times negative. Between negative 1 and 1, it's a good number to plug in is 0. 0 plus 4, positive. 0 minus 4, negative. 0 plus 1, positive. 0 minus 1, negative. 2 positives, 2 negatives, that's going to end up being a positive. Look, we're changing signs, right? Multiplicities are all 1. We're passing through zeros to negative values to positive values. Negative 3, positive, negative, negative, negative. This becomes negative. This is negative. That's negative. That's going to be a negative. Negative 5, negative across the board. Negative 5 plus 4, negative 5 minus 4, negative 5 plus 1, negative 5 minus 1. But a negative times a negative times a negative times a negative ends up being a positive. Right? Positive times a negative is a negative, times a negative becomes a positive, times a negative becomes a negative. Okay? Or again, multiplicities passing through. Or you can think about the graph of x to the fourth, opening upward, up, pass through, pass through, pass through, pass through. Positive values, negative values, positive value, negative value. Okay. Next one. It's not an equation with just like x's. It's got x cubes, it got x's, x squareds, x's. So move everything onto one side. Set the inequality to 0. Again, we're thinking about an equation right here because we know zeros are important numbers. So I'm just going to like start off with this. Okay. Oh, again, I didn't answer the question. When is x to the fourth? When is this thing greater than or equal to 0? When are we positive? We are positive here, here, and here. We are going to include this and include this and include this and include that because that's when we're equal to 0. So I would say there's two different ways. X is less than or equal to -4. X is greater than or equal to -1, less than or equal to 1. X is greater than or equal to 4. There's one way. You could say negative infinity to -4, including that. -1 to 1, including those. Remember, including are closed brackets, not including is the open brackets. And then from 4 to infinity. We don't include infinity. Infinity is a concept rather than a number. All right, this guy. It's not obvious. We can look to factor. We can look to factor out, divide out certain things. Right now, we're just going to look to factor by grouping, which sometimes work. It doesn't always work. The key to factoring by grouping is whenever we factor something out, whatever's left over, we need it to be the same in both. Factor out an x squared, it's x minus 3. Now, if I factor out like a positive 4, I'd have negative x plus 3. I don't want that. I want x minus 3. I want that factor to be the same. So I'm going to factor out a negative 4 to make sure that's a positive x and a negative 3. Now you have two terms, this term plus this term. They both share a common factor of x minus 3. What is left over after that x minus 3 is factored out is the x squared plus the negative 4 or the x squared minus 4. If you'd like, you can factor this to be x plus 2, x minus 2. You don't have to. Giving you solutions to this equation, 3, -2, 2. So break out your number line. You can look at this two-dimensionally or just one-dimensionally. This would be one-dimensionally, doing like the sign analysis. We're looking for what it's less than. These are all zeros. Okay, so we're not going to include them because we're talking about less than. This would be the same as less than 0. You can use test points. You can see that the multiplicities of all these roots are all 1, so you're passing through. You just need 1 to know the other ones since you know the multiplicity. So plugging in 4, positive, positive, positive. That's got to be negative. That's got to be positive. That's got to be negative. I just know it. It's got to be. You also think about x cubed. X cubed, there we go. Is that what it looks like for you guys? Yeah, like that. That's x cubed. So to the left, it's going down. To the right, it's going up. So starting at negatives, ending up with positives, passing, bumping in between. So when is it less than 0? Less than 0. Here. You could always use test points if you wanted to. Plug in 2.5. You would get a negative times a positive times a positive. That's a negative. Plug in -3. Negative, negative, negative. That's a negative. Two ways to write the solutions. X is less than -2. X is between, not including 2 and 3. Or from negative infinity to -2. And 2 to 3. Be prepared for both. Number 3. I'm going to start by factoring out a common factor of x squared. This leaves me x squared minus 7x plus 12. Is that less than 0? This can be factored. Normally, the two numbers that add to get negative 7 and multiply to get positive 12 are negative 4 and negative 3. So we have 3 solutions, 0, 3, and 4. Those are the roots, the zeros. Signs change around zeros. Here we go. We have a multiplicity here. Let's start over here at 5. Positive, 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 right? Positive squared, 5 minus 4, 5 minus 3, positive. Between 3 and 4, well, it's like at 4, this multiplicity is 1, we're going to pass through. At 3, this multiplicity is 1, we're going to pass through. But at 0, we're going to bounce. One way to do it. Another way to do it, use a test point. Let's plug in negative 1. A negative value squared is a positive. Negative minus 4, that's a negative. Negative minus 3, that's a negative. Positive, negative, negative, positive. Plug in something like 2. Positive, negative, negative. Again, it's positive, negative, negative. Plugging something like 3.5. Positive, negative, positive. That's a negative. Okay? One way. Another way. X to the 4th opens upward. Leading coefficient's positive. So it's going to be like that. So it's going to be coming from positives. We understand the multiplicity of 0 is 2, so it bounces off there. And then we understand that at 3 and 4, the multiplicities are 1, pass through, pass through. Okay? So when are we less than or equal to 0? Just here. That's when we are negative. Being negative is less than 0. 3 to 4, including 3 and 4. Here's one way to write it. Here's another way to write it. You need to be prepared for and comfortable with both. Okay. This is already set up for you. Set this equal to 0, we get negative 3 halves. Set this equal to 0, we get 5. A lot of people think 0 is a solution, but it's not. It's like this is not an x. If I plugged in 0, it'd be negative 3 times 3 squared times negative 5. That's not 0. So just because you see something extra factored out does not mean 0 is a solution. Here, x squared was factored out. That's why 0 is a solution, because you plug in 0 for x, you get 0. Not the case here. All right, now, yeah, maybe you want to, depending on the situation, maybe you want to use test points. Maybe you understand multiplicities. Let's look at the here. Like, it's probably the hardest thing to do is to look at the graph and to think, okay, this is going to be negative 3 times an x squared times an x. So that's negative 3x cubed. So x cubed looks like this, and then I can figure out this. It's like, that's kind of tough. Probably best thing to do is to start with a test point and then use your multiplicities. I like to start all the way to the right because it's easy. So it's negative 3 times a positive because it's like 6 something squared, whatever that's positive. 6 minus 5 is positive, so positive, positive. So this is going to be a negative. Now at 5, my multiplicity is 1. I'm going to pass through. So we'll go from positives to negatives there. At negative 3 halves, I have a multiplicity 2. I bounce off, so it's going to be positive here. Don't like that? Use test points. Plug in something like 0 between negative 3 halves and 5. You get negative 3 times a positive squared is a positive times negative 5. So like negative 3 times, this is a positive, 0 minus 5, that's a negative. That's a positive. Negative times a positive times a negative. Plug in negative 2. Negative, this is squared, so it's going to be a positive. This is going to be a negative. So again, that's a positive. All right, now when are we greater than 0? We are greater than 0 here. We are greater than 0 here. We are not including the zeros, though. So I would say from negative infinity to negative 3 halves, don't include it. And from negative 3 halves to 5, don't include it. Or x is less than negative 3 halves, and x is bigger than negative 3 halves, but less than 5. We do these sum number lines so often in calculus. So often. All right. Yeah, maybe you want to put everything onto the left side. I love zeros. I honestly prefer zeros, solving for zero than solving for anything else. Maybe then we factor out of 3. 3 goes into 48. What, 16? Probably 16. And then x to the 4th minus 16. This is similar to x squared minus 16, which is x plus 4 times x minus 4. X to the 4th minus 16 would be x squared plus 4, x squared minus 4. Okay? Making sure we understand that. So 3x squared minus 16, x squared plus 16, less than 0. 3x plus 4, x minus 4, x squared plus 16, less than 0. Now, what about x squared plus 16? Why can't we factor this? Isn't this x plus 4, x plus 4? Nope. You telling me it's not x plus 4 squared? Nope. It's not x plus 4 squared. X plus 4 squared is x squared plus 8x plus 16, right? You got that middle term, that 4x times 4x plus the 4x. So you might be thinking, oh, well, it's got to be something else. We got to be able to factor x squared plus 16. No, cannot factor that. It's actually something you can't solve. You set this equal to 0, you get imaginary numbers. Subtract 16 square root, you get the square root of negative 16 plus or minus 4i. You don't want x plus 4i, x minus 4i. We're just dealing with real numbers here. Inequality on the real number plane. So I'm pretty sure of that. No, I am. I checked. So the only solutions I have are negative 4 and 4. Now, it's easier with a number line than here, though you could do it. You could do it right here if you just like divide by 3. I'll show you this. Okay. Now, again, use a test point. This multiplicity is 1, this multiplicity is 1, so it's going to pass through those two zeros. So plug in 5, positive, 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 pass through, pass through. That's one way. So when are we negative? When is 3x to the 4th minus 16 less than 0? Right there. So negative 4 to 4, or between negative 4 and 4, greater than negative 4, less than 4. Other way I could have done this is divide by 3. Take the 4th root. Problem with this is that you get like plus or minus x is less than or equal to 2. Now, when this occurs, it's a little funky. You got x is less than 2, and you got negative x is less than 2. First one, solve for. X is less than 2. Wait, did I mess up? Yeah. Go back. My bad. This is not x squared plus 16x squared. This is x squared plus 4. Everything I said about x squared plus 16 can't be factored. X squared plus 4 can be factored. But boy, was this an error. Silly Mr. Mister. It's x plus 2, x minus 2. I hope it's frozen because my cursor's coming back. I literally have to unplug my display and then plug it back in, and then my cursor shows back up on my slate. There it is, it's back. The answers are negative 2 and 2. Everything else stays the same. Silly Mr. Mister. Okay, but let me show you how you do it the other way. Okay, I divided by 3. I take the 4th root. It's an even power, so I need a plus or minus. The plus or minus really should be staying over here on the left side. It's not the fourth root of 16 is plus or minus 2. The fourth root of 16 is positive 2. It's the fact that the original value could have been positive or negative. That's why it should be over here. Giving us two inequalities. When I divide this by negative 1, you remember from Algebra 1 days? You flip the sign, and we see x is bigger than negative 2 and x is less than 2. That gives me this. That gives me that. I don't know. Are you going to do that correctly? Maybe. I prefer, I didn't do this correctly, so who knows. But pick your way that you like and do correctly. All right, this is easy. I already got the roots all kind of laid out for us. Negative 3, 1, and 5. All the roots have a multiplicity of 1. So just do one test point and then know they're passing through. Pick 6, positive, 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 passing through this 0, giving us a negative, passing through this 0, giving a positive, passing through this 0, giving us a negative. If you did any other test point, it would confirm that. Greater than 0 or equal to, so including the 0, greater than, including the 0, including the 0, greater than means positive, so we got from negative 3 to 1, including. This is so frustrating. From negative 3 to negative 3 to 1, including, and from 5 to infinity. You can't include infinity. Greater than or equal to negative 3, less than or equal to 1, greater than or equal to 5. All right. Ooh, this guy. I'm going to factor out a 1/2. Ready? But this should be a minus because I'm just going to answer this question as it is. I'll do it 2 ways. X to the 4th, you take any number to the 4th power, it's positive. Plus 8, positive. You can't factor this. It's unable to be done as you see it. So X can be anything. So you could say negative infinity to infinity. That's one way. Or you could say X could be any real number. Okay. Now, I think the question was designed to be 1/2 x to the 4th minus 8 is greater than 0. Okay. Let me show you why. You can multiply both sides by 2. The entire sides, you can factor out the 1/2. You can do that. I'm going to multiply both sides by 2. Now multiply the entire side, what happens? You get x to the 4th minus 16 is greater than, this is just 0. And now this is the one that I factored in correctly, but I'm going to factor correctly now. It's x squared minus 4, x squared plus 4. And then this turns into x plus 2, x minus 2. You cannot factor x squared plus 4. So we solve. Negative 2 and positive 2 are zeros. X squared plus 4 would give us some imaginary numbers, which we're not worrying about. Use a test point. Multiplicities are 1 and 1, so they'll pass through. Plug in 3, positive, positive, positive. Pass through, pass through. So pass through the 0, pass through the 0. When is this greater than 0? This is what I think the question was originally intended to be. But I could be wrong. X is less than negative 2, x is greater than 2, or negative infinity to negative 2, don't include it. 2 to infinity include it. All right, next one. I'm going to move over the 30x cubes by subtracting. I'm going to factor out an x cubed, which they all share. I'm going to factor this. It's going to be negative 10 and positive 3. Since this is x, I have a 0 solution, a 10, and a negative 3. These are my roots. Using a number line. Make sure you put them in order. Negative 3, then 0, then 10. Okay. 0's got a cubic multiplicity, which means it bends through. 10 and negative 3 all have a multiplicity of 1, so it's going to pass through. Let's just do one test point and then understand that they will go through. It will not bounce off of. So plug in like 11, positive, 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 and then they'll change signs. And we are looking for when we are less than or equal to 0. That occurs here, including the 0, and occurs between 0 and 10. Including this 0. X is less than or equal to negative 3. X is greater than or equal to 0 and less than or equal to 10. Or negative infinity, negative 3 include. 0, 10 include. Factor out a negative 6 first. Make this a positive x squared. This will be a minus x. This will be a minus 2. Negative 6, keep that. Don't divide. Dividing messes things up. Keep the negative 6 factored out. I probably should have multiplied in the previous one, but since it was a number, it worked out. It changes the inequality when you divide by the negative. I think that's the key thing. X minus 2, x plus 1, greater than 0. So I don't have 0. 0 is not a solution. The solutions are negative 1 and 2. Okay? 0 plugged in to these x's doesn't give any 0. So plug in something like 3. These multiplicities are 1, so we're going to pass through. Plug in something like 3. Positive, positive, negative. So that's going to be a negative over here to the right of 2. Pass through the 0 to the positive land. Pass through the 0 to the negative land. It's a negative x squared, so it ends like that. So we'll be coming down from here. Negative 6x squared starts here. So we got negatives through negative 1 to positives through 2 to negatives. Two zeros. So when are we positive? Between negative 1 and 2, not included. Oof. Let me do the trick way to do this one. This is by factoring, by grouping. Different ways you were taught. You multiply a by c, and you rewrite this as, well, you're trying to find two numbers that multiply to get a times c and add to get b. It's negative 8 and negative 3. You're going to take those two numbers and rewrite your b term. This is like a step in undoing distribution, but you got to figure out like how to get this to be split up correctly. We can always guess and check, but the problem with guessing checking 4x squared is you got two options. You got 4x times x, or you got 2x times 2x. I don't know which one we want. So I'm going to do this one. Now we factor by grouping, just like we did before. I factor out a 4x. I have x minus 2. Whatever I factor out here, I better get an x minus 2 left over. So I know I need to factor out a negative 3, so I get a positive x minus 2. And that gives us, after I factor out of this term over here, the x minus 2, this term over here, the 4x minus 3, that gives us this. Set this equal to 0, you get x equals 2 and positive 3/4. Add 3, divide by 4. 4x minus 3 equals 0. Add 3, divide by 4. All right. Multiplicities are 1 for both of these. Make sure you put them in order, 3/4, then 2. Plug in something to the right of 2, like a positive 3. Positive times a positive, that's a positive. Pass through the 0 to negatives, pass through the 0 to positives, if you're thinking about the graph. Or just plug in values, test. When are we less than or equal to 0? We are equal to 0 here. We are less than 0 here. So we want that interval. From 3/4 to 2, including those values. Or this. X squared plus 2x plus 1. That's x plus 1 squared. When does that equal 0? -1. What's going to happen? You're going to bounce off. Plug in something like 2, positive. Plug in something like -3, positive. When is f of x less than 0? Never. No solution, whatever. When is f of x greater than 0? For all values except -1. This is the easiest way to write that. Instead of like -infinity, -1, and 1 to infinity, just x can't be -1. When are we less than or equal to 0? Well, we're equal to 0 at -1, and that's it. And when are we greater than or equal to 0? All real numbers. Okay, let's do some trig functions. Sweet. Sine of pi theta greater than √3/2. I like to, whenever we did this, we didn't do enough of them. Whenever we have this, I like to replace it with something else. And I say like, when is sine in general equal to √3/2? All right, so sine is positive in the first and the second quadrants. It's √3/2 when it's the taller 30, 60, 90 triangle. The taller 30, 60, 90 triangles are at the pi/3s. That's pi/3. That's 2 pi/3. So I'm going to say y is pi/3 or 2 pi/3. Well, y is not used. Pi theta is being used, but pi theta equals y. Divide everything by theta. Sorry, divide everything by pi, and this becomes, pi/3 divided by pi is just 1/3. So theta is 1/3. Theta is 2/3. So that's what I'm going to use. 1/3 and 2/3. It's probably best to figure out like what's going on in between, knowing sine will pass through like these zeros. It's not the 0. We got to be greater than √3/2. Like √3/2 is this y. And as we go in between them, we're going to have larger y values. Or plug in a value like, pi/2 or 1/2. And 1/2 sine of pi/2 is 1. That's bigger than √3/2. So that will be when we're like above √3/2. Will be less than any other sine value, where the y value is beneath these pi/3 y values. Anyways, you can keep going around the circle, but we are limited to 0 to 4. Hold the phone. We might have more. Yeah, this is pi/3. This is 2 pi/3. Let's find another angle. Go over 2 pi. So add 6 pi/3. You get 7 pi/3. 7 pi/3 turns into 7/3. 7/3, my friends, is between 0 and 4. Keep going. 2 pi/3, add 6 pi/3. That's 8 pi/3. So that's like the same angle location, but it's a different angle. Divide by pi, you get 8/3. That, my friends, is also in your interval. 8/3 is a little less than 3. So we got positive there. Let's keep going around and make sure 7 pi over 3 plus 6 more pi's over 3 is 13 pi's over 3. 13 pi over 3 divided by pi turns into 13/3. This is bigger than 4. This is out. We would stop here at 4. Start here at 0. So tricky, the fact that the interval made us look beyond the 0 to 2 pi range. Doesn't happen often, but when it does, boy, is it exciting. 1/3 to 2/3, 7/3 to 8/3. All right, same thing here. This one's probably easier to just figure out, but when does cosine equal 0? Cosine equals 0, that's when our horizontal is 0. It's the verticals. So that's when y is the pi over 2, 3 pi over 2. Oh, we got some negatives here, so hold the phone. Might as well start at like negative 3 pi over 2. Negative pi over 2. Not 0. Not 0. Cosine of 0 is 1. Pi over 2. 3 pi over 2. Now, that's not the values. We're looking at thetas. It's pretty easy. You're going to multiply by 2 over pi. It just becomes the numbers, the coefficients of them. It's like this could be 1, 3, 5, -1, -3, -5. So, anyways, maybe not necessary. -3, -1, 1, 3, 5, -5. Cursor's just okay, because like 5 pi over 2, that's another good one. That's outside the 0 to 2 pi range in both directions, but just add 2 pi, add 4 pi's over 2 to 1 pi over 2, you get to 5 pi over 2. So -5, -3, -1, 3, 5. All right, when are we less than? Whoa. There we go. When are we less than? 0. So negative. Okay. Let's plug in a value. We know cosine will always pass through 0. Okay, so I'm going to plug in 0. Cosine of 0 is positive 1. Okay. If I plugged in something like 2, the cosine of pi over 2 times 2 is pi. That's negative. You will be able to see, like, you would be changing signs, positive negatives, positive negatives. When are we less than 0? When we are negative. -6 to -5. -3 to -1. 1 to 3. 5 to 6. All right, we got to divide. Fun stuff. Good reminders. We sometimes divide to find roots and to factor things. I like long division. I like synthetic division. 2x cubed minus 4x plus 7x squared plus 7. Make sure things are listed. Whenever I press the erase button, it goes away. Make sure things are in whatever they call that thing. Highest degree to lowest degree. Make sure you're the cube first, the square second, that, then that. What needs to be multiplied by this to go into that? This is just the same as like long division, long division. 2x. 2x is like if you ever did 4 divided by 9,076. You know, like 4 times 2 is the biggest thing that goes into 9, right? What's the biggest thing that can go that this times this goes into that? 2x. That would get rid of this 2x cubed. We multiply 2x cubed plus 4x squared minus 2x. Like I have good runs and all of a sudden it just disappears. No, it's there. It was there. Anyways, we subtract, right? Subtract, bring down the 1, bring down the 0. Subtract. I like to add the opposite. I always find that I will make mistakes unless I add the opposite, especially like right here. Adding the opposite, these are gone. These become 3x squareds. This becomes negative 2x's. Bring down the 7. That's a 7. Okay. What 4 goes into 10 is the next thing you do. And again, you're like, okay, twice. 8 subtract. Right? Okay, so what does x squared plus 2x minus 1 go into 3x squared? Well, that's going to be a plus 3. 3 times the x squared plus 2x minus 1 gives me 3x squared plus 6x minus 3. Subtract those. I like to add the opposite. The 3x squareds are gone. This is negative 8x's, and this is going to be plus positive 10. That doesn't go into this at all. Okay, so we have a remainder. We're going to have a remainder over here, at least I think. Okay, so this is like 2. Bring down the 7. 4 goes into 27 6 times. 24, bring down the 6. Never mind. It doesn't have a remainder. Let's change that to 7. Okay, so this is 37. We go into 9 times. So subtract, that becomes a 1. There's a remainder. There ends up being 1/4 left over. So really quickly, I could show you with a calculator. And sometimes when you see this, you're like, oh, okay, that's why I always put this at the end. Take 9,077 divided by 4. You're going to see it's 2,269 and a 4th. Okay, 2,269 plus 1/4. Okay, well, that remainder 1/4. This remainder, negative 8x plus 10, x squared plus 2x minus 1ths, is left over, is the extra. Sometimes I like to have students rewrite it so that you say like this times this plus this works out. But whatever. So that'd be your answer there. Easy to use synthetic division with this. Now, what happens is we do a root. We don't use +2, we use a -2. We can only do this because this is a 1 in front. Okay? And then we use the coefficients. And if there's ever anything that's skipped, make sure you include a 0. X to the 5th, x to the 4th, x cubed, x squared, x, the number. Now, the reason why we use the root is so that we can do addition rather than subtraction, which is nice. We could actually do that with other ones, but this just works out. So that we bring down the 1 just like we normally do, but instead of like addition, instead of like subtracting the numbers with a +2, we add with the -2, which is what I like to do anyways. Here's the order. -2 times this. And that's like how we, anyways, I don't have to explain synthetic division. Negative 2 times 1 is negative 2. Add. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. This is the remainder. These are your x's, your x squared, your x cubed, your x to the fourths, fifth, fourth, third, second, first number. Whoops, my bad. These are your numbers. These are your x's. These are your x squareds. These are your x cubed. These are your x to the fourths. So the answer is x to the fourth minus 2x cubed minus 1x cubed x squared. It's ugly. Plus 6x minus 13 with a remainder of 25. X plus 2 is left over. I can check that if I want to. I don't want to. And do another synthetic. This one's another synthetic. It's just easier to do. I'll finish off with the last long division. Start with the root. That way we can add. We got x cubes. We got x squareds. We got x's. We got numbers. Bring down the first number. Multiply. Add. Multiply. Add. 8. Multiply. Thankfully, we get 1. These are your numbers. That's your remainder. Numbers first, then x's, then keep going up, x squared. So your answer is x squared plus negative 6x plus 8. Showing me that we could probably factor this, actually. Maybe not. Since this is not a 1, I'm not going to use synthetic. You can actually do this by dividing everything by 4 and stuff like that, but like I forgot how to do it, and if I forgot how to do it, you would forget how to do it. So I'm just not going to bother. Just do it the long way. Do it the hard way. Apparently, Mr. Huffaker's BC students like using long division, or they just feel more comfortable with it. Okay. 3x. 3x. Why 3x? Because 3x times 4x gives me 12x cubed. 3x squared. 12x cubed. Okay, so 4x plus 3, I get 12x cubed plus 9x squared. Okay, subtract. It's the same as adding the opposite. I'm going to do that so that I get the correct signs. Bring down the 9x. Okay, that fits nicely. If it didn't, I'd be really upset. So this is minus 5x gives me negative 20x squared minus 15x. Subtract, same as adding the opposite, Those are gone. This is 24x's. Bring down the 18. 4 goes into 24 6 times. 6 times 4x plus 3 is 24x plus 18. Subtract, we win. There's your answer. It's nice to finish off with 2 nice ones. All right, Mr. Messer out.